Okay, so I found another example of problem number 8. And we're going to work that out first. So they want us to find the vertical, the horizontal, and oblique asymptotes. Just remember horizontal or oblique. So our vertical is going to deal with the denominator. So I'm going to go ahead and write this down again because we want to figure out what's going to make it equal to 0. So we're going to factor x squared subtract 9x plus 20. So factors of 20 that add to get 9 would be 5 and 4. Since it's subtract 9x, we're going to have x subtract 5 times x subtract 4. And then we'd solve this out. X equals 5 and x equals 4. And so we have the two vertical asymptotes. Now, horizontal or oblique, so when we do that, we have to find out what the degree of the numerator is. So our numerator degree, and they use n for this, so n equals 3 because we're looking at the exponent. And our denominator is going to be 2, denominator degree, and they use n for this one. So then we figure out which one that follows on this sheet. So our, I don't know if my face shows up in y'all's recording or not, but I'm going to move it. So our numerator is 3 and our denominator is 2. So numerator is not less, it's not equal, but it is one more. So we have this n equals n plus 1. And I'm going to write that down on here real quick. So n equals n plus 1. And since it's n equals n plus 1, we have the oblique. So we know it's not horizontal. So there's none for horizontal. And we're going to have an oblique. So use synthetic division to find a line, y equals ax plus b. Now, before you do that, I want you to factor it out to the lowest possible. So our denominator is already factored because we had to do that in our first step for vertical. Now we're going to factor out the top, this x cubed subtract 64. And there's a formula for the difference of cubes, and I'm uploading that as well. So we have a cubed subtract b cubed, because the cubed root of 64 is 4. So a is x, b equals 4. So I have x subtract 4, because this is a subtract b times a squared plus ab plus b squared. And that's on the other paper. This is past material. So we have x squared subtract plus 4x plus 16. Okay. Now if I wrote these two over each other, x subtract 4 times x squared plus 4x plus 16 over x subtract 5 times x subtract 4. We're simplifying this rational expression before we divide so that we avoid unnecessary steps. So those cancel out. I don't need those. But at the same time, now that I've simplified this down, since these two cancel out, this one is not a vertical asymptote because they canceled each other out once we simplified it. So there's only one vertical asymptote, which I don't think I said that on the previous problem. So let's, since these two canceled out, there's only one vertical asymptote. Might have made that worse. Might need to do another one after this one still yet. Oh, now then we have, this is our numerator and this is our denominator left. So we're going to go ahead and do that synthetic division. X squared plus 4x plus 16 divided by x subtract 5. So remember when we're doing synthetic division, we're trying to get this, our leading, to look like this. So X times what is x squared? We have x, so we have x times x squared. X times -5, so subtract 5x. Then just like long division, we're subtracting it, so change the signs. 4 plus 5 is 9x. Bring down our 6 because we didn't use it. X times what would be 9x, so, and it's positive, plus 9, and we'd have 9x. 9 times -5 would be subtract 45, sign change, and that would be 51. But we don't need our remainder on this because we just want to, what's the line look closest like. So our oblique asymptote is going to be this. Send me all your questions on this because this is probably the hardest one. Number 8. Okay, let's go ahead and move on now. Find the vertical, horizontal, and oblique asymptotes, if any, for the following rational function. So x to the 4th subtract 1. What subtract 1 is 0. So our, and on this it's an even exponent, so x equals 1 and -1. Because 1 to the 4th power is still 1. -1 to the 4th power, it'd be that negative times a negative, so it's going to be positive. So both of those will be this vertical asymptote. Now then, to find our horizontal or oblique, we need to know the degree of the numerator is 2, and the degree of the denominator, which they use n for, is 4. So n is less than. And so on that one, when we have less than, it's y equals 0, and it's horizontal. So we have function as 1, y equals 0. There is no oblique because it's one or the other. All right, horizontal over here. Okay. Number 10. Oh, these are long. Okay. But we don't need our. Yeah. For the function f of x equals 1 plus 1x, graph the rational function using transformations. Use the graph to find the domain and range. Use the final graph to list any vertical, horizontal, or oblique asymptotes. So plus 1 on the outside. This is referring back to our 3.5 and 4.3 stuff. So that is not included here, so it's not left or right. So we're going up 1. Same thing here. So that's left, right, up, down. And if you don't remember that, go get them papers from 3.5, 4.3, wherever I introduced them. And then this is your reciprocal function. So this would have been 3.4, I believe I gave y'all that paper. You're going to have to refer back to them on this because this stuff we've done. All right, domain. So our domain, is there an x value we can't have? There's x's here and there, so x cannot equal 0. Range, so now we're looking at our y values. So right here, x cannot equal 1. And then, should I keep both of these shown? Y'all need to see that still. Okay, so vertical asymptote. Our vertical asymptote would be x equals 0. Horizontal would be, there is 1, and it's y equals 1. And there is not an oblique one because we had horizontal. Okay. 11. For the function f of x equals 7 plus 1x, graph the rational function using the transformations. So plus 7, so we're going to go up. So right, down, left, up. The domain, y'all really can't see that well. I can't really see it well, but we have this one going down like this, and this one's doing this. So x cannot equal 0. Then our range, it's this line right here, and it's going to be at that y cannot equal 7. I know this is a really crappy graph, but I hope y'all's is better. The left vertical asymptote, vertical asymptote, so we just have this one at x equals 0. So there's one, it is x equals 0. Our horizontal is going to be, so vertical, I can't see anything I'm doing. Vertical is x equals 7. Horizontal is y equals 7. And so no oblique. And I'll go ahead and fill in these spots when y'all are looking at them. Lord, I hope I put them in there in order. Horizontal is y equals 7, and there is no oblique. 12. Now this one's on the inside, it's plus 5. Remember when we had them on the inside, it's opposite, so this means left. So shift down, left. Okay, so left, so this one's ours. This one down, right, up. The domain, so our x values, x cannot equal, what is that? 2, 4, 5. X cannot equal, and it's -5. Our range, there's nothing down here, so our y values are greater than 0. Greater than 0. Okay, let's do this. Vertical asymptotes right there would be x equals -5. Horizontal asymptote. Now remember on the asymptote, it's not an inequality, so it's equal sign, so it's y equals 0. Because it can't equal 0, it's everything above it, but equal sign. And then there's no oblique because we had horizontal. For the function 1 over x subtract 10, so remember it's opposite world when it's on the inside, so this is right, down, right, up, left. It cannot equal +10. Then our range, so same thing, so it's like greater than 0, greater than 0. Vertical asymptote, so vertical up and down, there's one of them, and it is at x equals 10. So I don't, it's like I have to decide which one to write on, so it is x equals 10. Horizontal, just like the last one, so it's y equals 0. It is y equals 0. There's not an oblique, so I need to get these papers in order to upload them because they're all kinds of crazy right now. And then I'll get these uploaded. I expect lots of questions from this one because there's a lot of stuff you have to put together for this one. The difference of cubes, rationalizing or simplifying rational expressions, and synthetic division. You have to put a lot of what you've learned previously throughout the years together to be able to do this one. So I expect all the questions. Don't feel bad asking them. I'm going to stop this video.